Hey guys, so in section 2, we're going to take what we learned about the laws of exponents with multiplication. We're going to kind of apply them and tweak them and change them around a little bit to allow for us to divide instead of multiply. Okay, so this first one is a quotient of power. So when you're dividing two things, notice they again still have the same base. Instead of adding the exponents, you're going to subtract the exponents. Okay, so hopefully that makes some sense. I like to think of it this way. If you have like x to the fifth over x squared, okay, you could think of it as subtracting and doing x to the 5 minus 2 power, which is 3. The way I kind of imagine it is I have 5 x's on top, and I've got 2 on bottom. And what happens is they fight each other, okay, and cancel each other out, right? Those two kill each other, and these two kill each other. And what are you left with? You're left with 3. And where are they located? They're located on the top, right? If the 3 were left on the bottom, it would be 1 over x cubed. But because it's on top, it's just x cubed over 1, which is x cubed. Okay, so that's kind of how the quotient of powers works. The other one is the power of a quotient. All right, so similarly to when you had two things multiplied in parentheses and you're raising to an exponent, you kind of distributed that exponent. You're going to do the same thing if you're dividing. Okay, so you could distribute that m to both the top and to the bottom. Okay, so you can check out their two examples and work along with me as I do these 12. Okay, so we're just going to simplify these and work from there. So this first one, right, notice they have the same base. It's okay, it's a number instead of a variable. The 5's not a problem. But we've got 5 5's on top, 2 on bottom that cancel each other out, and you're left with just 3 on the top. So 5 cubed, which we can actually figure out, 5 times 5 times 5 is 125. Okay, number 2, I've got 6 m's on top and 4 on the bottom. I'm going to do this one the other way. Think of it as just subtraction, okay? So m to the 6 minus 4 power, which is m squared. Okay, you can kind of think of it either way. You're going to have to develop your own methods on these to make sure you can handle all these problems. Okay, and number 3, I've got to combine the p's and combine the n's. For the p's, I've got 5 on top, 2 on bottom. So p to the 5 minus 2 power is p cubed. And n to the 4 minus 1 power, remember that n is the same as n to the first, is going to be n cubed as well. So p cubed, n cubed. Number 4, I've got 2 a's on top, 1 on bottom. So a to the 2 minus 1 power is a to the first, which is just a. Number 5, okay, the x's, we've got 5 on top and 5 on bottom. They just cancel each other out completely, and they're going to be completely gone, right? Because that's x to the 0 power, which is just nothing. You have no x's left. And then for the y's, we've got y to the 3 minus 2 power, which is y to the first, or just y. And number 6, now we're going to throw some coefficients in there, so you just have to simplify this fraction, okay? Negative 2 over 14 simplifies to negative 1/7, okay? So I've got a negative 1 on top, which we don't actually need to put there because when you take the y's into account, that's going to be y to the 7 minus 5 power, which is y squared. So negative y squared on top, and on bottom we have that 7. All right, and number 7, right, if you look at the x's, there's 1 of each, so they cancel each other out completely. And the y's, we've got 6 on top, 4 on bottom, so we're left with 2 on top when they cancel. Number 8, now we're going to start raising these two exponents. So remember that if you have an exponent on the outside, it has to be everything has to be raised to that. Okay, you could simplify on the inside first and simplify those a first, or you could raise to the exponent first and then go from there. Really your call. I'll do this one by raising to the power first, everything. All 4 of those things need to be raised to the 3rd power. And then I'll show you in number 10 and number 11 and number 9 how to do simplifying on the inside first. Okay, so we've got 2 to the 3rd power, which is 8. That's the big step that most people forget, is to raise that number to that power. Then a to the 2 times 3 power, because that's power to a power, which we learned last section. So that's a to the 6th, b cubed over a cubed. Now we're not finished yet because we could still work with these a's. Okay, so we've got a to the 6 minus 3 power, so it's going to be 8a cubed b cubed. Alright, so number 9. Now I'm going to simplify on the inside first and then raise to the power. Alright, I'm going to do parentheses first. So I'm just going to look on the inside of here. That 4 over 3 I can't do anything with, so just leave it as 4 over 3. The p's have got 4 minus 2 power, or they fight each other and we're left with 2 p's on top. And for the r's, we've got 4 minus 2 power, which is again r squared. Okay? Now this whole thing I need to raise to the third power. So I need to remember to distribute that third power everywhere. Okay? We've got 4 to the third power, which is 64. P to the 2, oops, P to the 2 times 3 power, which is P to the 6th. R to the 6th as well, over 3 cubed, which is 27. Maybe the worst handwriting I've ever had in my whole life. Okay, and the last 3. I'm going to zoom in for these a little bit, if I can. I can't. Great. So for number 10, okay, simplify on the inside first. That 2 can just hang out. I'm left with 1 R on top and no W's. They just cancel. And I need to raise that to the 4th power. So I need to raise both the 2 and the R to the 4th power. So 2 to the 4th is 16. And R to the 1 times 4 power is R to the 4th. Number 11. Okay, simplify on the inside first. We've got 3R, well, just 1 R left, and 2N, so N squared over 2. Raise that to the 4th power. Okay, so distribute this everywhere. You've got 3 to the 4th, which is 81. R to the 4th, N to the 8th, all over 2 to the 4th is 16. And lastly, number 12. Okay, we'll start with the n's. All right, if you combine the n's, we've got n to the 7 minus 3 power, which is n to the 4th. All right, we've got r to the 7 minus 3 power, which is n to the r to the 4th, and then t squared, those cancel each other out. And that's our final answer. So the second part of this is now we're going to have to work with 0 and negative exponents. We're going to do everything we've done so far. We're just going to add on 0 and negative exponents. If you read this thing at the top, it's going to lay this out for you, what 0 and negative exponents really mean. Okay, so 0 exponents, anything to the 0 power is just 1. It always equals 1. Okay, so those are the easiest things of all time. It doesn't matter if it's x or 430 or 0.0035. Okay, it's always going to be 1 if it's raised to a 0 power. Right? Negative exponents are a little bit more difficult. Right? In order to get rid of the negative part of an exponent, you're going to move that exponent to the other side of the fraction line. Okay, so 6 to the negative third is 1 over 6 to the third. Okay, I think that's easier to see when you actually are working in problems, but these are the two basic things that you need to know for this part. All right, you can check out their example, and we'll do some together. So to start here, right, I've got 2 squared over 2 to the negative third, obviously same base, which is good news for us. All right, there's 2 ways you could think of this. One, you could think of it still as subtraction, okay? But that's going to be, yeah, I'll do this one 2 ways. 2 to the 2 minus negative 3 power, right? Remember that 2 minus negative 3 is really 2 plus 3, so it's going to be 2 to the 5th power, okay? So you could think of it that way and just go with that. All right, 2 to the 5th power comes out to 32. So you can be 2 to the 5th or 32. Or you can think of it this way. The way that I kind of work with these is whenever I see a negative exponent, I circle it and I draw an arrow to the other side of the fraction line. Okay, so I can see that what this problem really is with positive exponents is 2 squared times 2 to the third. Okay, and I know how to do that. They've got the same base, so you just add the exponents, so you get 2 to the 5th. Okay, which is, again, 32. All right, so either option is okay. You could just do subtraction. All right, the key is you can't have negative exponents in your answer. Okay, so you got to remember that if you have a negative exponent in your answer, you need to just switch it around and make sure it's positive. So let's move it to the other side of the fraction line. All right, so number 2. All right, we'll do it this way. Pick this up, move it to the top. So right now I have 1m on top. I'll write this out. You don't always have to write this out. You got 1m on top. I'm moving 4 more up there. So now I've got m to the first, m to the 4th. Those can be combined because they're the same base. So it's m to the 1 plus 4 power, which is m to the 5th power. Now number 3. Number 3, this 8 on top, the negative 8, needs to be moved down to become a positive 8. So what this is 1 over p to the 3rd, p to the 8th. Okay, p to the 3rd, p to the 8th can be combined to make p to the 11th. So I've got 1 over p to the 11th power. All right, now if you just subtracted that, you're going to get p to the negative 8 minus 3 power, which is p to the negative 11th power. which you would have to change to 1 over p to the 11th to not have negative exponents. Number 4, right? In this case, you're moving the negative 4 down and the positive 5, or the negative 5 up. Okay, so in order to rewrite this with all positive exponents, it's going to become b to the 5th over b to the 4th, which is a problem like we just did on the other side. You got 5 on top, 4 on bottom, so when they cancel out, you're left with just 1 on top, so just b. Number 5, here's our first 0 exponent. This is so easy. Don't do anything here because all that thing to the 0 power is equal to 1. Okay? So this problem is really just 1 over 4w to the negative first y squared. Okay, now everything here is good except I've got that negative exponent. So that w to the negative first has to come to the top. Now notice that I just circled the w, not the 4w, because that negative 1's only working on the w. The only way it'd work on the 4 is if there was parentheses around the 4 and the w. Okay, so I'm going to rewrite this as w over 4y squared. And that's your final answer. Okay, number 6. Got to distribute this squared in. Okay, we'll do that. And at the same time, I'm going to move that ab to the negative 2 all the way up. Notice this time I'm picking up both of them. Right, I'm picking up both of them because there's parentheses around the a and the b, which tells me the negative 2 power is working on both. Okay, so that a to the 2 times 2 power is a to the 4th. Then we've got b to the 6th, right? And then I've got an a, b quantity squared, right? So I have to also distribute in the 2 when I move that. So it's going to be an a squared and a b squared. All right, now I can combine things that I have the same base. So a to the 4 plus 2 powers, a to the 6th, and b to the 8th. Number 7. Okay, first thing I notice is the 0 power, right? Y to the 0 power is just 1, so it's not doing anything. Just cross it out so I don't get confused by it. Then I need to pick up the negative 2 power on the x and move it up top, so it's x to the 4th times x squared, which is just x to the 6th, because you add the exponents. Okay, number 8. Okay, the first thing I need to do is distribute the squared in and just do the power to a power on the bottom. So I've got 6 squared is 36. That's a very commonly missed piece of the puzzle. Alright, make sure you do the 6 squared. Alright, then a to the negative 1 times 2 power is a to the negative 2 power. And then b to the 1 times 2 power is b squared. Over b to the 8th. Okay? Alright, so a couple things need to happen here. So I've got this negative 2 power that's got to move to the bottom. 36 stays on top because it's not in parentheses with the a. Right, and then the 2 and the 8 for the b's I need to simplify. So I've got 2 on top, 8 on bottom. When they fight each other, you're not going to have any more on top. You're going to have 6 on the bottom. So the answer is going to be 36 over a squared, b to the 6th. Okay. Number 9. He's getting a little bit more and more complicated, except number 11. That's the easiest one ever. You can look ahead to that one. But for number 9, in order to get started, I need to distribute in the squared. All right, and then at the same time, I can start moving negative exponents around. So pick up that u and pick up the r and move them to the other side of the fraction line. So I've got 3 squared is 9, r to the 1 times 2 power is 2, obviously, and then t squared. And then I also moved that r to the top, so I've got 1 more r to the first that came from the negative. On the bottom, I've got a t squared, a u to the 7th, nothing happened to those. And then I've got 4 more u's coming down to the bottom from the negative 4 power. So now I can just combine whatever needs to be combined. Okay, the 9's not changing, there's no other numbers in there, so that's going to hang out. Alright, the r's, I've got 3 on top, none on bottom, so I've got an r squared there. The t's, I've got 2 on top, 2 on bottom, so those can cancel completely. And the u's, I've got none on top and 11 on the bottom. So the final answer is 9r cubed over u to the 11th. Alright, number 10. So for number 10, you could I'd start by distributing that negative 1 in, right, before we do anything else. So we've got m to the negative 3rd, t to the negative 5th over m to the negative 2nd, t to the negative 3rd. right, then you're going to move everything, right? All these things need to move to the other side of the fraction line. Okay, so I've got m squared t cubed on top, because I moved both of them up. And on bottom, I've got m cubed t to the 5th. Okay, so the bottom's going to win in both of these battles, right? If you look at the m's, you got 2 on top and 3 on bottom, so you'll have just 1 on bottom when they all cancel. And with the t's, you've got 3 on top, that's the worst 3 of all time, and 5 on bottom, so you'll have just 2 on bottom when they cancel. So 1 over mt squared. Remember to have the 1 over, that's really important in these problems. Alright, number 11, easiest problem ever. Whole thing's to the 0 power. Anything to the 0 power is 1. Okay? And the last one. Actually, the last one you can go ahead and do on your own.